Here's problem 4, written by me. This one's a number theory problem again. Suppose the sum of the digits of a positive integer n is 2024. How many possible values are there for the sum of digits of n plus 1? The sum of digits in this case can really only refer to one sort of idea. I guess there are multiple, but the most common one is the fact that divisibility by 9 is the same as sum of digits, right? So in other words, a number is divisible by 9 if and only if its sum of digits is also divisible by 9. Or if we call this S of n as the sum of the digits, then we actually know that S of n is congruent to n mod 9. If you haven't seen mod notation, it just means that these two values, n and the sum of the digits of n, leave the same remainder when divided by 9. In this case, if we know the sum of the digits is 2024, then the most intuitive answer for the one possible value for n plus 1 is just 2025, right? As an example, think about the number 111, right? 1 2024 times. Well, clearly, when we add 1, that just gives us 2025. And in fact, if we think about what we do, like just think about the addition for a second, right? We have a bunch of numbers, right? And then we add 1. In most cases, when we add 1, it's actually just A, B, C. All the letters, I guess all the numbers are the same, except the last one, which increases by 1. However, there exists a thing called carrying, so it's not always this simple. What if we had, for example, instead of this, maybe the number ended with like 8, 9, and we added 1. Well, instead of 8, 10, we would carry and it would become 9, 0. So if we think about how the sum of the digits changes, we go from something 8, 9, which adds up to 17, or at least the part that changes, into 9, 0, which becomes 9. As we can see, we're actually reducing the number by 8. And to rationalize this, we think about what would have differed in these two cases, right? Typically, we add 1. But now, when we're adding 1, a 9 becomes a 0 instead of a 10, and then the next number increases by 1. So the change that we see in this case is a minus 9 and a plus 1, right? In other words, in total, we get a minus 8. So we can see that when the ending number is 9 and we have 1 carry operation, the number goes down by 8. But there's more possibilities, right? And it really depends on how many 9s are at the end of our number. If we have 2 9s, and maybe the next number is not a 9, and we add 1, we get this number adds 1, but these two both decrease by 9, right? In other words, if there are 2 9s at the end, then we will add 1 and subtract 9 twice. And we can see that if there are, in general, k 9s, then we should expect the sum to decrease. So then we would say the sum would decrease from the original value by 9k minus 1. So it would increase by 1 from the non-9 digit, but it would decrease by 9 for every 0 digit, right? So we can see that, therefore, in this case, we can expect when we add 1 to always be, so in this case 2024, subtracting 9k minus 1, in other words, 2025 minus 9k. This actually confirms the idea that we had here, right? In that, okay, that just means that the sum of the digits of n plus 1, well, that also increases by 1 if you think modulo 9, right? if we have a number whose sum of digits is 2024, then that number must have been congruent, right? Left the same remainder when divided by 9 as 2024 itself. And then so when we add 1, it should leave the same remainder as 2025. Therefore, the sum of the digits must also increase by 1, or be equivalent to 2025 modulo 9. In this case, okay, that just tells us that, well, for the set of possible answers is just the set of all possible values of this expression, where k can range, as we can see, from 0, in which case, where the number does not end in 0 or 9, and all the way up to, well, how many possible numbers can we end with 9 here? Well, we can see that, for example, okay, well, we can have like a bunch of 9s at the end, and then some number, right? And then we can see that, well, in this case, n plus 1, that becomes like this, right? So how many possible 9s can there be? Well, 2024 divided by 9, that just becomes 2. And we can do that, right? 2, 2, 4 with a remainder of 8 mod 9. So k can go up to 2, 2, 4, which gives us the possible numbers 0, 1, all the way up to 224. And therefore, our answer just must be, well, the number of possible k, right? And in fact, those correspond to 2025 all the way down to 9, all those multiples of 9 up to 2025, which gives us a final answer of 225 numbers in this list. So that is our answer.